So we are MarCATing Group 3. So today's topic would be data regression, and I am Anson.
I'm Jojo.
And I'm Andrews.
I'm Hunky.
I'm Eamon. I'm Judy.
I'm Patrick.
I'm Eddie.
So as you all see that we have a dress code red and black. So it's resemble to the theme of Squid Game. So let's get started. So our topic will be data regression, and here is the table of content of today. And it will be divided into 6 parts. So first of all, we'll explain about what is regression. And second, we'll give out some examples of regression. And third, what would happen to data if there is an outlier. And then would be the exciting moment for the games. And the fifth part would be the other application. And last would be the Q&A session. So first of all, we would like to ask a question. What is regression? Regression is a statistical method to use it to draw relationships between dependent variables and one or more independent variables. So it aims to see if any independent variables changes when dependent variable varies. So the first type of regression would be linear regression. So linear regression is an analysis to predict the value of a variable based on the value of another variable. So it is a supervised machine learning algorithm to find the best fitting line that minimizes error between the predicted and the actual target values. So a coefficient of determination as well as the squared mean, R squared, would be measured how well the regression line approximates the actual data. So moving on would be some application of linear regression. So first of all, it helps to evaluate trends and sales estimates. So it helps to predict a salesperson's yearly sales, like to make some business decisions. So next, it would be some analysis on pricing elasticity. So it can help to predict how consumer behave with price changes. And next would be some risk management for insurance company. Regression can help estimate claim costs to assist business decisions. And lastly would be sports analysis that helps to analysis of teams' numbers of game to predict the win rate. And another type of regression would be polynomial regression. So polynomial regression is an extended version of linear regression. So it helps to model nonlinear relationships between a predictor, variables, and outcomes. So it helps to measure relationships between a dependent and independent variable. So, but this time with degree. So you can see on the figure is that polynomial model is a curved line. So it helps, but it shares the a common way is that they all use mean squared error as the loss function and R squared as matrix to test the variations. So next would be the application. So it can help, polynomial regression can help to predict death rate. So it can help to mitigate consequence of disastrous events. So next would be oncology treatment. So it basically is a cure for tumors. So polynomial regression can help to estimate the tissue growth rate to monitor ontogenic growth. So it helps to the medicals to make decisions. So next would be speed controls. It predicts drivers' behavior and inform when necessary as preventative measures. So next would be Jojo introducing the remaining regression types.
Okay, let me to introduce the next 2 regression type. First, for the logistic regression, it is a supervised machine learning algorithm. We usually use logistic regression to find a relationship between the 2 factors and use them for predicting the probability of binary outcome event or an observation. You can see the photo. Logistic regression usually look like an S-shaped curve, and we can predict 0 to 1 range. And logistic regression usually limited to two possible outcomes, true or false, or even 1 or 0. And this is the formula of logistic regression. It forms with the y, e, beta 0, and beta 1, 2 is orchestra. Y, it means that the probability that dependent variables, which means the outcome, that is equal to 1 or given to the independent variable x. And e means that the base of the natural logarithm, which usually approximately equal to 2.7. And beta 0 is the intercept of the model, which means the S shape. And beta 1 and beta 2 is the coefficient for each of the independent variable x. And then we usually apply the logistic regression in our real life. For example, we usually use it to predict the disease. For example, we will use to predict the presence or absence of a disease, for example, heart attack. And then the possibility of the heart attack is the why we want to get the result. And we usually base on the patient's data like age, weight, gender, or exercises. It means the independent variables. Secondly, we use it to predict the student performance, such as predict whether the student will pass or fail the exam based on the student's assignments, attendance, or participations. And lastly, we use it for predict the game performance. For example, League of Legends, we usually use the logistic regression to predict which team will win the game based on their teamwork skills, players' statistic, or previous ranking. Moving on, I will introduce the multiple linear regression. Multiple linear regression is the extension of linear regression. We use it to find the linear relationship between one dependent variables and two or more independent variables. We use it to forecast a new observation or even control a process. And this is the formula of multiple linear regression. Also, it forms with y, x, the independent variables, and the intercept of the regression line, and the beta 1, beta 2, which means the coefficient represent the change in y for one unit change in the corresponding x. And then e is means the error terms, which means the residuals. We use multiple linear regression to calculate the p-value or t-statistic. Also, we will use multiple linear regression in the real life. For example, we will use it to predict the consumer behavior. We use multiple linear regression to analyze how the independent variables, such as age, income, education levels, or social status, will affect the spending preferences. Secondly, we use it to predict the crop growth, such as we will use it to analyze the environmental factors. Temperature or rainfall will affect the crop yield. And then lastly, we use it to predict the level of police confidence, as we can analyze how the demographic factors such as gender, ethnicity, marital status will affect the crime rate in the society.
Okay, so thank you very much for the definitions of the regression. So we have just mentioned 4 of the regression types. We got like polynomial, logistics, got the linear of course, and the multiple linear. And for now, we are going to get some of the examples to show all of you. Hope you guys can look at regression visually. And we will explain about the outliers. What if there is an extreme value in our regression? How it will affect our function or formula? So we are going to keep things simple. We're not going to talk about polynomial logistics. We're only going to discuss linear regression. So how do we calculate linear regression? So we always know this line is the best fit line. We always say it's the best fit line. But actually, simply, we can say linear regression comes down to only 2 words: estimate and the trend. So what we are doing is to minimize the sum of squared errors. What is the sum of squared errors, you might ask? You can see from this line and the data points.
their distance is the errors, and we add all of them. And then, of course, we square them. So that gives the name sum of squared errors. And how do we minimize it? So you can see the equation here is the equation of us learned in secondary schools. Y hat is the estimate. So the estimate of this best fit line equals to mx plus b. M is the slope, b is the y-intercept. So by looking at this point, y1, and from this, the y value of the best fit line, we can get this equation sort of here. Looks difficult, but actually it's basically this point, the y value of this point, minus the y value on the best fit line, and you add them all up, give them a square, you get this equation, and blah 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 blah. After multiple simplifying and a little bit of partial derivatives, you get the results of these two equations to show us how do we get the slope and the y-intercept, which is for the slope is the mean of x times mean of y minus the mean of xy over mean of x squared minus the mean of x squared. And you can see the y-intercept is mean of y minus the slope times mean of x. So don't worry about the calculations, and remember these two formulas. We'll be using it shortly in our example. So we'll do some little bit of examples and the tug of war of Squid Games. We are going to do a little bit of an example to show does strength matters in the tug of war. So is it like more strength equal to less time of victory, a quicker win? Well, obviously might be, but let's do this visually. So by this formula is quite simple in how we can get the slope of the best fit line. We need to calculate the mean of x, mean of y, mean of the xy, and the mean of the x squared. So just do the maths, okay? Add them all up, divide by 4, mean of y, mean of x squared, and the mean of the xy. You get these 4 values, and you plug those in. Okay. And you got these 4 values, plug them in, and for the y-intercept, you get this formula, minus 0.44x plus 17.8. So the slope equals is negative, of course a negative relationship. Technically, more strength equals to less time of victory, which is obvious, right? So it boils down to this. What if we got another value, an outlier we call it, an extreme value? How will it how can an outlier affect the value of our best fit line just calculate?
Thank you, Hunty, for introducing the example of this regression. And I'm here to talk about an outlier. Have you watched the game Squid Game, especially the first episode? I'm sure you all watched. And this is we are talking about an interesting game, which is tug of war. And we all have watched the game tug of war that not only strength can affect how you win the game, but also we can use some of the techniques how to pull the string, or even some of the female characters who appeared very weak, but they have a lot of strength, not matters with their size. So I'm now talking about the outline. You can see this point, which is far behind of the best fit line. Yes, and we can see the XY, which have people that have a strength of X, you can see is more weaker than the original values, but you can see the time of victory is 5. So that like some of the female characters in Squid Game, they can still manage to win even if they don't have more power or strength than some of the male characters. And you can see the mean of X, mean of Y, and mean of X squared and XY have changed the numbers such as this. 20 and switch to 17.6. So we can see that with one extreme value that matters a lot with the best fit line and all of the data. So as you can see that this 4 point is the original point and this is the outlier, which is the extreme value. You can see that the best fit line is here. The point do not have the trend of more power with faster wind. So we can see that this is the complicated formula. So we can add the result in the y equals to mx plus c in this formula. So normally we will reject some of these extreme value because this affects the best fit line a lot. So I'm not here to say some of the complicated things, but now let's pass the time for you guys. Do you excited about being some of the Squid Game? So I will pass the game to Andy and Hendrik to hold the games. Wow. Yeah, very excited.
Thank you, Adrius and Aki. After the informative and technical part, let's play some games. So in this section, we will have 2 games. The first game is red light, green light. So are you guys ready?
Yeah.
So the game objective of this one is provide hands-on experience in using linear regression and to analyze whether there is positive or negative relationship between students' reaction speed and their winning speed. So before the game starts, we need to collect some data for the game. So I will pass this part to Andy.
Okay, so each team please select 2 players first to compete in this round of our game. So select the 2 players, please scan this QR code and go to the human benchmark website to test your reaction speed time. You need to do it like 5 times. Yes, yes.
We want the ones to play the game.
Just 2 people do the test.
Yeah. We want 2 participants. Let me know if you have any 2 of them.
It's okay, we have 2 rounds of game, like
One more.
almost everybody can join. So
Everyone can do.
okay, select the player, please scan the code.
Yeah, sure. You can save the score first. So you're going to
Scan the QR code and do the reaction time test first. Yes.
2.
And you wait till the green light and then press as fast as possible. Yes,
You can have your best record.
yes just click.
Try again.
And this will be your this. So maybe you do it again.
Yeah, 5 times.
Yeah, because this is like extreme method. Maybe mark down time after it.
We will collect your reaction
Like
speed.
this.
Then we will use it.
Only the one who participates
You have to do it 5 times.
recording there.
Just the players.
Don't refresh.
So if you guys finished the test already, please submit your result via this
Scan the QR code on the
Results.
And then click again. And wait for it.
and you save your reaction time on it.
And then please, in the name section, please mark your team number as well.
Yeah, please follow the format.
我知道啊，你人嘅平均係人嘅平均係0.26，人嘅平均0.26，做到1為止。
Nice.
Day 2.
And you can scan the code outside
Like total like 5 times. You will get the
and
average
save your
reaction speed.
and your team.
So if you guys ready, the 2 representatives, please come here.
Oh,
After submit the result.
And after submitting the result, you can come out.
Yes.
Please come here.
Did you submit the Google form? Submit it? Okay, very nice, very nice.
那你什么嘛？那你跟我学过的。那你喜欢吗？采气球。
一棒全部给他的。
Don't worry, no exposure, no exposure.
Yes.
No balloons report.
Yes.
Very little game, very little game.
You want to choose?
Let's go.
Okay, everybody out, everybody out.
Alright, so please listen to the rules of the game one. So the rules of this game is the two players must stand back to back like this. Yeah, back to back, and then with a balloon between them. And then teams
Yeah, but you
must
can't touch each other.
have 5
Yeah, you gotta.
This finish line.
Okay, come here, come
While
here.
keeping
Come
the
to the
balloon
starting point.
between the bags, if the balloon falls, we can
You maybe, yeah, you maybe twist. One guy facing in front, one guy facing back.
Players must freeze immediately. If anyone moves after the slogan ends, they must go back to the start again. Stop this game to cross to the finish line successfully and get a prize. So, are you guys ready?
Are you guys ready?
Maybe in this direction, you can show.
Alright.
Make some noise. Are you guys ready?
Wait, start from the beginning. Please start from. Wait, please start.
Alright.
Please start from the beginning.
I'm saying the slogan now. In 3, 2, 1. You can move. After the slogans, please stop. Alright.
Start. Listen to the rules, please. Listen
Ready?
to the rules. Don't touch it. Okay.
Alright. おこわこちびやすみだ. Yeah, when I say the slogan, you can move. Alright. Now you need to stop because the slogan ends already.
Yeah, when
Yes.
the slogan, you can move.
Alright. おこわこちびやすみだ. Okay. Ready? おこわこちびやすみだ. Alright. おこわこちびやすみだ. Alright, they are the first one. First one. おこわこちびやすみだ. Then, you guys do need to join. Yeah, it's alright. 3. おこわこちびやすみだ. Okay, they are the second team and the third team.
Okay.
Yes, you go to the point. Yes. Yes. おこわこちびやすみだ.
So we will give a prize to everyone who joins the game. Yeah, you guys can do it.
Thank you for your participation.
Thank you so much.
Hello. Okay. So actually we have to collect data first, but right now we can set up the Excel together. Okay. So everybody got Excel installed on your laptop? Yes. Okay. So listen very carefully. Okay. This might lead you to a MarCATing. Okay. So first, okay. So for the ones who don't have, haven't never do regression in Excel before, you should set up your Excel first. So first, you should press File on the top right corner and select Options on the bottom left corner. Okay. And then you have add-ins. Okay. And you can click Go when you selected Excel add-ins. And then you should have this window, and you can click the analysis 2-pack. If you take it and click OK, then you should have the data analysis in your data column. And for MacBook users, you can go to Tools and select Excel add-in as well, and take the analysis 2-pack and click OK. And you should also have the regression analysis in your data column.
Please let us know after you install the 2-pack.
Okay, so let's now move on to the Excel part. So everybody got an Excel ready? Okay, so right now you can copy our data. So we have two data. One is the X variable, which is the reaction time from your reaction time test. This is the explanatory variable, which is the independent variable. Okay, so the Y variable is the time you use to win, which is the response variable and the dependent variable. Okay, so we can input the data together.
You guys can keep the data together.
Okay, so everybody got the data input in your Excel? Okay. Everybody got your numbers ready? Okay, okay. So actually, not yet. Okay, okay, okay. Okay. Everybody okay? Okay, so actually we don't have to do the calculation by ourselves because we now have Excel. So we can actually run regression on Excel. So there's actually two parts. The first one is the one we mentioned. Then we can use the data function, which is data analysis. So we have to select all the data, just highlight them, and we have to include the title as well. Okay, and then we click data analysis. Okay. And then you should choose, you can see regression here. Everybody follow? Okay, so when we choose regression, we click OK. And then we can input our Y range. It's the Y variables, okay? Remember to select the label as well, okay? And then we click Enter. Okay? And for our X range, we select here, the X variables, reaction time. We select them all and click Enter. Okay, everybody follows? And after that, remember to take the labels box, or else it will think the reaction time column is also data. Okay, and we can select our output range right here. So you should select output range first, and then we click here. You can select output range around here, okay, and then click Enter. So everybody follow? Okay, so after setting up all of this, you can just simply click OK, and then we will have the summary output of our regression analysis. Okay. And so from our calculation mentioned before, we can have our R square and have our intercept here, just by the output. Okay. Okay, everybody follow? But like, you may think like, oh, but it's like so many numbers. I don't really know what the numbers means, right? And I don't know the relationship about this too. So we can actually visualize the data by selecting the data
Okay, and we got insert here, and we have the recommended charts. We can select the scatter plot and click OK. We should have the scatter plot here. But what about the best fit line? So actually we can do it with a simple click in Excel. We happens to have a quick layout here. We can choose this one, the 9th one, layout 9, and then we just choose the quick layout. So we will get our equation. We have the slope, we have the intercept, and we have the R squared. Okay, so and we also have the best fit line. Okay, so as this case, we can see maybe there's errors in the test, and the sample size is too small. So actually it happens that in this case, the reaction time actually is not that matters to the time used to win the game. Okay, and we can see because the R squared is lower than 0.5, which means that R squared means that how much does the data fit the regression model, and we can see the data actually does not fit the regression model in this case. So that there are many data points are not on the best fit line, and the R squared is smaller than 0.5. Yeah, but actually for like your normal like data analysis, you will get like more normalized data. So I'll give you an example like this. So actually, if everything is normalized, we can see that we get greater best fit line, and we will get R squared, which is bigger than 0.5. Okay. So everybody now understand how can we do regression analysis, linear regression analysis on Excel, right? Okay. So everybody can have those two outputs, right? Okay, okay, okay. Because after the next game, you're gonna do it on yourself, okay, to win the MarCATing.
So make sure you understand how
Okay, so everybody okay? So now we're gonna move on to our next game.
The next interesting game is Glass Bridge. The objective of this game is to reinforce your knowledge by applying the method that we just taught, and then use linear regression to analyze when there is a positive or negative relationship between students' assigned weights and stage of survival. So for a total of 12 players, like 3 players from each team. So each player will draw a secret weight. Please make sure to not let others know your assigned weights. And then after I count down of 3, 2, 1, all players must choose and jump to either left side or right side here. So once everyone has chosen a side, we will sum up the total weights of players on each side. The side with the heavier total weights will break, and all players on that side will lose and fall from the bridge. So the game continues until there is only one final survivor, and every player has 2 lives. So you can lose twice. So let's start.
Okay, so every team, please.
Please assign.
Yes, three players. 3 players.
Come on.
Yeah, don't be shy. You might get a chance to win MarCATing, guys. MarCATing.
Oh, it doesn't matter.
You want a MarCATing?
Doesn't matter.
Okay, single line, please. Line up in a single line. Everybody, please line up, okay?
Please line up and then draw your assigned weights.
Yeah, please don't show anybody your weights, okay?
Keep your weights secret. And then please line up in ascending order, please.
It may be an advantage or a disadvantage, so don't let others know your ways.
Okay, you can show your letter to others, but not weights, okay?
A, please line up here. Who is A?
Ascending order, ascending order.
Not the left artist.
Okay, please show your letter. Okay, show your letter. Show your letter to others so that we can carry your ways, guys.
Who is A? Okay, please come here. Ascending order, please. So make sure everyone. So are you guys ready? Alright. So make sure you decide either left side or right side after I count 3, 2, 1. So let's start. 3, 2, 1. Please jump.
Okay, stay still, stay still.
Please wait.
Number. Letter is
Okay, don't share away to the others.
Letter. Okay, thank you. Okay, thank you very much.
Okay, so the side which is gonna break is left side. Oh no, -1 life for the player on the left side.
Yeah, so please line up again. Everyone please line up again.
Yeah, but don't worry, you still got 1 life left. Okay.
Okay, round 2.
Ready?
Ready? 3, 2, 1.
Jump!
Okay, stay still. Okay.
Letters, please. Letters.
I-L.
N-U-G. I. And K, right? Okay.
Okay, so for round 2,
Round 2.
which side is the heavier? Left side!
So if you lost twice, please go back to your seat.
Okay.
So ready for round 3?
Okay, the rest, please line up again. One single line, please. Okay. You're closer to your net con, guys.
Alright, ready? 3, 2, 1. This
Jump! Oh, please stay still, okay?
Alright, let's see.
Okay, so for round 3, the side who is losing is right side! Oh.
So if you lost twice, please go back to your seat.
Okay, so the remaining player, you're the lucky ones. You have to line up again for round 4. Round 4, guys.
3, 2, 1.
Jump! Oh! Okay, so for round 4, the loser is Lisa! Oh, we still got 2 players left. Please line up. We're gonna have the final winner, guys. Okay, so ready? Which team is gonna win?
3, 2, 1.
Jump! Okay. So we're gonna have the final loser of the game is Bryce. Congratulations. Okay, so actually everybody have a chance to get a MarCATing. How are you going to get a MarCATing? Is to finish the regression analysis on your own, okay? Using the data we have on the glass breed, okay? So actually we have the weights already provided for you, okay? And here are the rounds survived. Okay, so everybody please input your data into the round survived and weights, okay? So as we demonstrated, so you have to output the regression analysis output and then have the graph also with the best fit line and the equation. The fastest 3 who get output will get a MarCATing, okay? Let's go. Okay, remember to select the right X and Y variables, okay? Okay, we got a prize here, the MarCATing, guys. Everybody have a chance.
The fastest possible to get
First 3 got a net point.
Oh, I think we got a first winner. Let's check if the answers are correct.
Need graph with backward line and equation.
Congratulations!
Yeah, congratulations!
Okay. Oh, last race. I count 3, 2, 1, and then the fastest will get.
Okay, congratulations to all winners. And I hope everybody. Oh, one more!
No. Like everyone.
Okay, I count to 3, okay, and then you raise your hand, okay?
Yes.
1, 2, 3! Oh, sorry guys, maybe next time. Okay, even though you don't got a MarCATing, you have the ability to calculate regression analysis on your own right now, okay? So let's move on to the next part.
So, isn't these games exciting? So after this fantastic game, we're finally move on our last part, which we'll discuss about how we use regression to apply on a daily basis. So
always using as this responsible tool to help us to calculate and help us in decisions and predictions. Especially we will use it on stocks, sales, or maybe exchange rates, etc. But today we're going to talk about these three sectors, which are financial forecasting, analysis and predictions of weather, and healthcare and medicine. So before we move on, let me ask you a question. Do you think that nowadays in many areas, especially in Hong Kong, people are talking about one topic, which is house pricing? So how do we manage to use a lot of data that we see online, maybe on TV, to help us to calculate the house price? Well, based on the size, location, number of rooms, etc., these kind of data that let us to put in the regression line to help us to calculate those price. For this formula, we can see we could use the size, location, school, age, etc. We could put in the formula to calculate our price. However, when we wanted to invest of real estate, how do we do it? We will see through the LEITS, which will provide a steady income stream through dividends, and also it will offer diversification beyond the stocks and bonds. So you can see there's an image showing us the LEITS returns, non-LEITS returns. So whenever we want to get some investment in real estate, we want to see these regression lines to see how many returns we are earning. So that makes us be more efficient, convenient to help us to get to the investments. So, okay. So the next thing is that when will be the regression be used in company or investors? So we will see the capital access pricing model, CAPM. So it's basically using the regression to determine the expected return, especially they're using a rigs to calculate the expected return. So it's normally used by investors to see that when the assets is fairly priced, and for some companies they will use it to the constructions of the portfolio by balancing the risks and returns so that they could be managing their company in a more efficient way. So these are all the financial forecasting using the regressions as an example. Later on we will talk about the weather, so I'm gonna pass on the time to Judy.
So I'm now going to talk about the analysis and predictions about the weather. So first of all, let me ask a question. So how can we predict the weather? Or someone may think about we predict by the past experience or the occupations, but these methods are not very accurate. Using the regression is more accurate in fact. So why is so important to predict the weather? So in general, it helps us to reduce the potential damage. For example, if the farmer knows the heavy rain is coming, they can take some actions to control their loss. In our daily life, we can just thinking about, do we need to bring an umbrella, or how can we dress today to make us feel more comfortable? So as we can see in the graph, the black one is the actual humidity, and the red one is the predicted humidity by using the regressions. And we can see that the location of the two circles is very similar. So it tells us that using the regressions to predict the weather is quite accurate. So how can we use the regressions to predict the weather? First of all, we can just build up a model. For example, we can simply use the linear one to predict the temperature by using the dates, like the years of the date. But we can also use more advanced models, like we can incorporate different variables, so the outcomes will be more accurate. And then we can analyze the data. For example, we can know that from the graph and know that in summer there will be a rise in temperature, and in winter the temperature will be decreasing. So therefore, we can predict temperature in the future. Let us know that the temperature will normally rise in summer and normally decrease in winter. The regressions analysis shows that there are clear correlations and seasonal analyze the data collected from clinical trials from the cases. We can find out the relationship between different variants, like how do the drugs affect our body health, and we can help us to determine the treatment, and we can compare it, and you can comparing the patient's outcome, so we can find out the best treatment to give out to our patients. So the other one is the risk assessment of disease. So we can find out the relationship between the lifestyle and illness. For example, in the graph shows that the people who smoke more will have a higher percentage population to get a heart disease. And opposite, if we like to work, then we will normally have a less opportunity to get a heart disease. So this shows that the regressions can help us to analyze the impacts of various risk factors like smoking and age. So it can help us to generate target approach to help us to improve our life. So that's the end for our presentation, and from the Q&A session. Does anyone have any questions?
Thank you.
Thank you for your question. As we can always use the regressions in sales. For example, we can get some information from the markets, like how our customer age is, or how they will behave in customizing our good. So we can get these ideas and put into the like Excel or the regressions to help us to generate more platform to make our sales become higher.
Yes.
Thank you for your presentation, and I want to ask because you guys mentioned the application of this method is mostly in prediction in different fields, right? So is there any like method or like measurement to evaluate whether your prediction is good or not?
Oh, that's a great question. Thank you. So we didn't mention it during our presentation, but you can see when you are generating your graphs in Excel, so you got like an R-squared value, right? That we always call goodness of fit. But what does it tell us? It's actually showing how much your data spreads from the best fit line you have calculated. So if R-squared is 0, it is not that better than a mean. So y equals to y to the mean, right? So a line in the middle, so it doesn't show any relationship. I hope that's what I get from you. So if R-squared is 0, it means that no relationship at all. A mean isn't that better than the trend at all. But we have said this is for R-squared can be a good measure to measure how good your best fit line fits the data. So the higher it is, closer to 1, technically it's the better, but you need to avoid having a R-squared value too high, because it causes overfitting, which is a great problem in a lot of applications, particularly in machine learning. So we are always trying to avoid R-squared too high, but not too low as well. Yes?
Thank you for your presentations. Usually when people want to do regression analysis, usually we call Excel, right? But I wonder, is there any alternative application that we can do regression analysis? Because if everyone always uses Excel, then that's your analysis will similar to others, not outstanding.
Yes, we do have a lot of different applications that can also generate regression or other data analysis or analytics, like Tableau or Google Analytics, which is they are the tools like you can very easy to use because you can just drag and drop and then to the components, and then you can they will automatically generate regression to you with a nicely formatted.
Yeah, Excel is just like a tool to help you calculate the regression analysis. And so if you want different analysis, you can use like we have like linear regression, we have logistic regression. So these are the methods. Like you have like a different analysis on the same thing, but like Excel is just to like a calculator.
And also, I would like to add, we have learned R programming, right, in the couple lessons beforehand.
Yeah.
And actually, the package GT12 has functions to calculate regression, and you can display a load of regressions by using various functions. I'm not gonna go through that as time constraints, but R programming is actually another way that we have actually learned in this marketing research section. So maybe apart from Excel, so like the tools that you mentioned, there are a lot of tools you can use.
So I'd like to ask, are there any assumptions need to make when we use this model in marketing research?
So, I mean, if you want to, like, of course there's assumptions, so definitely according to logistics regression, if you can see the line, it's like an S-curve, right? So you assume the data is only consists of two values. That's one of the assumptions. True or false, binary, 0 or 1, like this. This is one of the assumptions. And the other is, sometimes we do assume if our sample size is too small, we assume that it approaches to the population distribution. So that's another assumption. As you can see in our example, the sample size n is equals to 4. This is really a small sample size, but it facilitates our explanation. So that's another assumption in hand. So like our data, we assume approaches like similarly to the population distribution. So we hope to use this limited data we have so we can explain it, the trending among like when we are looking at the population wise. So we hope to use little data to explain it, that the effect it has on a large population.
Okay, Yvonne?
Yeah, I have a question about the list sum square part. Because you said we are calculating the differences between all the data point and align. So why we are using the vertical differences instead of the shortest differences? We are using the difference in the y value, right?
Yeah, we're using the y value.
But
And
actually the shortest difference is
vertical, right?
yeah, vertical.
So yeah, but the vertical is actually has the same x value, right? So we are comparing the y value in these 2 points. So this best fit line is mx plus c, right? Mx plus c. Y equals to mx plus c. This point is equals to mx plus c. So do you agree on that, right? This point is x1, y1. These 2 points got the same x value. So this distance should be the difference on the y value. So that's why we are comparing. We want to minimize this distance overall.
Because when we are talking about distance, mostly a distance of between a point and a line, usually we calculate the vertical.
You mean the
Perpendicular distance, right?
Why we are not using that?
Because if you're calculating perpendicular, the x value is not going to be the same.
Yes.
It doesn't
Because we're
represent.
trying to compare with the best fit line. So if we're trying to use the perpendicular line, it would be another x
So
value.
look at this. So these 2 values are showing different independent variables. So we aren't using the perpendicular distance. Although, right, the perpendicular is the least amount of distance. But we're trying to minimize this distance. We are watching in the slopes, right? When I draw a line like this, vertically, we can show the distance. We can calculate the distance. And soon you will approach to the best fit line, which uses derivatives, to be honest. But ultimately, we're trying to make the distance having the same x value, and we're trying to minimize the y distance. If that.
But why we need to have the x having the same x? Because the point of using the sum square is just to minimize the error. But since the error is minimized, it has nothing to do with the x calculus.
y, but y is the dependent value. Y depends on x. So we need to have x to be the same value.
Because the whole
Because
thing
you are not-
is x depends to y. So we cannot change the x value.
That's a different value if you are using a perpendicular distance.
Yeah.
It's just two different values. You can't compare those because they are not the same. The independent value is not the same. Just like, let's use our example, strength x to the y variable, time to win. So if you're sorry. So let's say perpendicular distance. So at this point, strength is 25. If you use the perpendicular distance, the strength is 24. It's not the same. So the trend line is trying to give an estimate, like for future estimations, the trend. What if we got this value, right? This is it's not perfect, but this is the equation we have. So at this volume, our estimate is minus 0.44 times this number. This is what the lines tells us at x equals to 25. The value of the y is minus 0.44 times 25 minus 70. So you can't just, the point is y depends on x. You cannot change the x. And by using perpendicular distance, you're not comparing the same independent variables. Yes, I hope I can answer.
You have to have the x value, right? Constant, compare the y, variations. That's what the concept is. That's why we look at the vertical line, each one. That's the concept. Maybe if you want a bit more time to absorb, ask us later. Do some reading about the line structure. In fact, you got an expert here who also study finance, right? Understand statistics. Have you studied statistics? Alright. Variable dependence. Okay. Think about it, ask us next week, the following lessons if you're really interested in this area. Good job. Oh, by the way, Hanky, tell us your name again. Tell us your name again quickly. Let's tell, I think they recognize. You have to write everybody say your name, that's okay, same time. Everybody, this is the. Let them introduce their name to you once again. Listen carefully.
I am Hunky.
Hunky, how about you?
I'm Anson.
Anson. Jojo. Amen, of course. Judy.
I'm Patrick.
Okay, the door. Danny. Andres. Thank you, Andy. Andres. Everybody get up and again. Cool. Okay. Everybody stand here, take a picture.